Well, hi, and thanks for joining me in my shop here. We're going to go to the next step with this Grundig radio. I've kind of hit the end of the road when it comes to trying to align this on the FM side. If you watched the last video, and the last videos, actually 3 of them I think, as I try to align this, first struggling with information to work with, which I finally got a hold of. But no matter how much I twiddled the adjustments inside this radio, the FM sound remains garbled and distorted. So I've concluded that I'm not going to get anywhere with alignment. The problem lies elsewhere, somewhere in the components, or unfortunately maybe a weak tube, which is going to present me a bit of a problem. So I can't do much about the tube right now, but I decided I'm going to go ahead and check all the voltages on the tubes. And the reason I've been avoiding this with this radio, even though I have a schematic, is because these tubes in here are quite unusual in how they're constructed. And from underneath here, I can't tell which pin is which one's pin number 1, pin number 2, without an awful lot of studying of the circuit layout and trying to identify one of the pins by what components it's connected to and all that kind of stuff. That sounds like too much work to me. So what I'm going to do is simply hunt for high voltage on each of the tubes, and when I find it, I know which tube I'm working on. I'll be able to look at the schematic. The schematic has a fair bit of information about tube voltages and stuff like that. And hey, one of my microphones is swung the wrong way, so let me just re-aim that. Okay, so hopefully that didn't make any noise while I did that. I had the microphone swung over to my new microscope area. Yeah, if you just watched one of my most recent videos, you'll see I've acquired a pretty nice microscope, actually a precision instrument, but unfortunately it was really badly abused. So I cleaned it up and it's over in the corner waiting to help us look at some interesting stuff when we find it. And that's why my microphone was aimed. But even before we start this radio, I got another strange thing to show you and say, what is it? Honestly, the first time I saw this thing, I was absolutely clueless as to what it might be, and I suspect most of you will be too. So I'm going to try to hide the hints, the manufacturer's name and stuff like that. And you can try to tell me, what the heck is this thing? Check it out here. Okay. Now this connects to a complex control box through this wire, which again I'm not showing you, but you can trust me, it's just a small box, and there's some control adjustments on it for this thing. What is this thing? This rod doesn't go anywhere, it's a little bit loose in here. Maybe you can unscrew it and take it out, that's probably what that is. So, ground connection here. What is this? That's my challenge. Again, if you absolutely know because you have some direct experience with it, don't blurt the answer out. Let some people take guesses. It's always interesting to see what kind of creative notions people come up with when they see something like that. I certainly got an idea in my head which turned out to be absolutely nothing to do with what it did. But, so anyway, now, on to the radio. So, the way we're going to do this, we're going to use my vacuum tube voltmeter, because I like the indicating pointer on it, on the old meters. I don't like the digital ones quite as much. There's my indicating meter there, and I just like looking at the pointer. There's something about it that I think lots of people are the same too, who do this kind of stuff. They like the pointer. In fact, some digital meters come with fake pointers to try to imitate the pointer, but they really don't quite do it. Especially if you're looking at a voltage that's jumping around. Seeing those numbers jump around doesn't do me any doesn't do me much good. Okay, now what do we need to do here? We need to turn on the radio. We need to have the sheet ready here. In fact, I'll turn on the radio, let it warm up, and I'll figure out which tube is which and start. So let's switch it on here. Volume down. Quick safety check. There's no antenna on it. I really don't care what kind of sound comes out of it. It's on now. A little hard to see in the video camera, but it is on. And now I got to read these voltages relative to something. And there's a heck of a ground bus bar runs around in this radio. And I'm not so sure that the chassis is really an element or something that we should read voltage to. Look at the power supply down here. And there's a connection to the chassis for the vacuum tube heaters. Yeah, there's another connection to the chassis on the negative side of all the filter capacitors. So there you go. So we can read the chassis. Here's all these chassis connections here. Assuming this is chassis and not that wire. You know what? That could be that coat hanger like ground bus that's running through there. Well, you know what? Time to experiment. That's what I say. So the set should be plenty warmed up now. Plenty warmed up. I should use I got lots of clip leads now. I should be using color appropriate clip leads. So I'll use black for the ground. These tricky to squeeze clip lead, most annoying things ever. Okay. And first we will try to the chassis. So I'll just find something nice to clip onto here. There we go. And B plus should be visible. I'm just going to flip to the meter now. We're on the 150. Let me put it on the 500 volt scale and we'll read the B plus here. So there we go. So on the 500 volt scale, about 200 volts of B plus there. And on the other side of the filter capacitor, we've got, what's that, 175 volts of B plus. And this is with a little bit of restriction. The supply voltage, line voltage, it's 117. How do you like that? Even with light bulbs in series. I got enough juice in here that 117 volts is left over for the radio. Perfect. Now let's read the voltage to that ground bus. See, I don't see anything happening at all. Let me put you on the dual view here, just one sec. I'll make just a little video change, make this a little more presentable. Here you go. So I'm tapping the that ground bus in zero action on the meter, so I'm pretty sure that ground bus is tied right to the chassis. Very good. So let's pick any particular order we should do these in. Do them in an order I won't forget them. Let's see, there. The position is mapped out on the back of the cover here. 3 across the back, 2 further in. Well, why don't we start with the output tube, EL41. Third one in the corner by that power supply transformer, which is this tube here. So looking at the schematic, the EL41 output tube has 3 elements in it: grid, screen, and suppressor. So I should be looking for a plate and a screen voltage. Oh, they actually have the voltages written right here. 220 on the plate, 240 on the screen. Wait a minute. I thought the screen's supposed to be a little lower. Maybe that's 210. Pretty close to the same voltage, 220 and 210. So let's go hunting. Hunting we will go. Okay, first this one. What are we getting there? We're getting about 200 there. Pretty sure that's the plate, to be honest with you, because I see it going right over to the output transformer. So that's got to be the plate. And the screen is going to be somewhere else on that tube. Once again, that's the plate voltage. 200. Now, getting at the screen's just a little more scary here. Trying to get my lead down in there without shorting anything out. Ooh, plus there's that problem. Making me jump. That's probably a grid or something like that. There we are. I think it's 180. So bingo. So screen and plate fine on the output tube. Next one. The next one we'll try is this EBC41. This is the detector tube. 75 volts on the plate. No screen. So we should just find 75 on the plate. I don't think there's much voltage put on the two diodes. One of them's not even being used, I think. There's two diodes in this tube. Oh, okay, so where is that tube? EBC41. EBC41, whoops. EBC41 is one in the back beside the transformer. At the transformer end. One at the back, so it's right there. Of course, it's going to be close to the output tube, isn't it? Now, this might get noisy. If I hit the grid with this, you might hear it. How about this spot? That sounds like a grid, doesn't it? Okay, how about this spot? Ooh. There we're reading. What? See, now that's way over the 75. That's interesting. That's 170 volts. What's the other side of this capacitor? Slightly negative on the other side of the capacitor. But on the other side, 175 volts. Okay, let's go around. Well, what's over here? So that's where it's coming from. It's coming from over there. What's over here? Okay, that's the other side of another capacitor. You can actually see the dust from the high voltage. Oh, there's another change capacitor down under there too. I can certainly tell it's been changed by the soldering and connection technique that was used. Yeah, okay. Back to the tube. How about this spot? Nothing. Okay. That's grounded all over the place there. How about this one here? Watch out, I'm using my left hand. Here we go. Nothing. How about these ones down here that are all... Well, these are grounded. So it really doesn't boil down to very much. This guy, this guy, this guy. Pretty curious about this one. So, what am I finding out here? I'm finding out the voltage on the plate is much higher than it's supposed to be. That's a little odd. Okay, so it's coming off of a 210 volt line. 210 volts. 210 volts through 300k of resistance. Isn't that odd? 300k of resistance. Supposedly there's, if I'm reading that right, 0.5 0.45 milliamps. Half a milliamp. I'm reading that right? I don't think I am. It's probably supposed to be 45 milliamps. Wow, where's the voltage drop in there? So, okay, keep that in mind. Plate voltage of detector is high. Let's go on to the next tube. The next tube is an EF41. There's two EF41s in here, side by side. One of the three at the front. So, you should find similar voltages on here. These are the IF tubes. Okay, just starting any old place. Let's start right here. You got a little bit of a voltage there. I'm still on the big honkin' 500 volt scale. That's like, there's your 75 volts. Wait a minute, did I get things mixed up? No, EF41. So I'm back here. It's supposed to be... I can't read their writing here. 187 volts. So I'm looking for 187 volts. There's a screen grid in here. 60 volts. 60 volts on the screen, 187 on the plate. So maybe that's the screen. That's right around 60 volts, isn't it? Okay, that's good. Now I've got to find the plate. That's grounded. That's grounded. Here's one. Oh, here's one. I can see the dirt on the wire. So this is probably the plate right here. Hold on to your ears. No. No noise. Hard to get a contact there. It's so dirty. So we're looking at one, well, it got around 150. So that's a little low. Okay. But they basically, I'm checking to make sure they both have voltage, which they do. Now we'll go to the next EF41, same thing, same voltages. So this is the other one. Okay, let's go down here. Nothing at all there. Let's try this one. So that would be the 187. It's actually around 160. That's probably the plate. You can see the dust on the wire again. Now, maybe this. Holy smokes! It's hard to get in there. Nothing. An even harder one to get at. Oh boy. Let me just take a better look at that before I... Okay, no problem. Before I short something. Here we go. There we go. Oh, that's not very high. Well, that's your 60 again. So there they are. There's the two voltages on there. Now the radio does work in AM just fine, so I shouldn't really expect a problem here. What are we left with? We're left with one more tube. Come on, we're almost done. So I've done the, yeah, one more tube. The ECH42, which is the mixer tube up at the front of the radio. ECH42. There are the voltages that we're supposed to find there. 200 on the plate. There is a screen. Oh, this is a complicated tube. Okay, so that's going to be the AVC line going to the grid there. And that's a screen. I don't understand how they've done this. The screen is 50 volts, so 250. 200 volts and 50 volts on this tube. Which tube? Where is it? What's going on? Where am I? Why am I here? It was an EBC 41. No, ECH 42. ECH 42. Okay. That's this one back here. Okay, here's a dusty, dirty wire. $160, $170, something like that. So that would probably be the plate. It's going into one of the IF coils or some kind of coil there. So that all makes sense. Okay, we'll try this back here. Did I see a voltage that went away when I touched it? See, I'm having trouble looking at the meter and what I'm doing at the same time. So get the probe ready, look up at the meter, touch it. Seems like a slight negative voltage there. And let's try this one over here. It looks like it might have some high voltage on it. That wouldn't be much. There we are. There's the 60. Did I hit the plate voltage on this one? Be careful. That's the 60. This is the high voltage one here. Yeah, I did, didn't I? Yeah. Okay, so the tubes have appropriate levels of voltages at them. So that leaves us, unfortunately, that leaves us at another dead end here. You know, the part of this radio which is driving me nuts is the discriminator circuits, the FM detector circuits, whatever you want to call them. I had not spotted them on the schematic here, so I don't know. Hey, you know, there's one more tube, and that's the magic eye tube, which is, there's no magic in this eye tube. And we should be, let's see if I can get at it easy. And the answer is a big yes, you can get at it easy. Tip this radio like this. Never forgetting that it's on. Down in there. Voltmeter lead here. Okay, same basic idea. Switch back to the meter view. I must have tugged my camera wire there. Okay. Tiny little voltage there. Oh, there we go. There's the B plus. Well, there could be component failures in there. Oops. Here's the so those components on this is the back of the magic eye socket in the radio, and any of those components, there'd be some large resistors there. They could have gone high. Something like that could have happened. Most likely, the tube is a dud at this point. That's the most likely thing. Unfortunately for magic eye tubes, apparently In some cases, the phosphorus used in the magic eye to make the glow has a life, and even sitting idle, they wear out. Not absolutely sure of that, but I think that's what I heard. So where are we on this radio? We're at the point of I don't know what to do next. That's where we are on it. Because it sure seems to be working well, except for this distorted FM. And why don't we hear some of that, and then I'm going to shut it down. We'll just play a little FM here just to sort of convince me that it is not working. FM antenna. Volume. So close. Not bad, eh? There, you can definitely hear the
Gary Burton on vibes and dreams so real.
You know, now
that features the compass. Well,
I'll tell you what my imagination says. When you listen to that,
very, very young. Pat Metheny.
okay, and you hear the sort of sound in the guy's voice. His voice has been modulated by a very, very low tone, and it makes it that funny garbled sound. I hear this quite a bit on radios. In my mind, what I think that is a decoupling capacitor. That's a capacitor that's supposed to shunt alternating current signals to ground to get them off of things, such as the AVC bus and other DC supplied voltages to tubes that are common, like say the screen voltage, which is supplied essentially from the same supply, and if you're not careful, you'll exchange signals between the tubes along these screen voltage wires. And so what's done is a capacitor is put in place to essentially drain out any AC signal and just leave a nice clean DC sitting there. Now, these are pretty high frequencies we're talking about, so normally they're fairly small capacitors, and I suspect what's happening is one of these draining capacitors or decoupling capacitors has lost its capacity, and the symptom of that is it can no longer drain the lower frequencies because it doesn't have enough capacity. And because of that, some low frequencies end up leaking into parts of the radio where they're not supposed to be, and the result is you hear them as this modulation of the sound. That's my theory. I have no clue if it's really true. Now that would point to a bad decoupling capacitor. I wonder if I should just identify them. Maybe there's a couple that are critical. Maybe there's not a lot here to do to make a difference in this respect. Or maybe I can test for it. How could I possibly test for that? I would want to look at one of these DC bus lines, or as said in the more modern vernacular, rail. I don't normally use that term with these old radios. Look at these different rail voltages and figure out which one of these 75 capacitors is the problem. Kind of see the difficulty in that, eh? The decoupling capacitors are all over the place here. And so, but that's not something I can stand here and do. I have to study the schematic, identify a few choice ones, and go at it from there. I think that's the logical next step. There's another even more logical next step, though. I could put this radio aside at this point and go on to another one. And the logic there is there could be more fun that way. Okay, I'm going to vote in favor of fun. I'm going to set this guy aside. And for now, I'll let the juices run around in my brain a little bit. And maybe I'll come up with a better idea than the one I just spit out. And that'll be it for this radio for now. I gotta go get another one. So thanks a lot for watching the series so far. I'm still hopeful we're going to get this thing working. The challenge with this radio now is if it is a tube that's causing this effect, I don't have a replacement. You know, I do have a replacement. I have one replacement tube. It's EL41. Well, that's the output tube. And I'm sure it's not the output tube. So there we go. See you on the next video.